Thank you.
I will tell you when you are ready, okay? When you are live. Uh-oh, error. Let me try again. I don't know why it is error. Okay. Okay, let me see if the recording is okay. All. Let's go. Just a moment. It's happened. Just a moment. Now.
Good morning, good afternoon. Good
not yet.
Accept.
You can.
Good morning, good evening, good afternoon, everybody. My name is Melissa Esposito, and I am from Italy. I am a high school math teacher, and I'm interested in different and various projects, including a twinning projects that allow twinning between different European schools. I have been teaching for more than 28 years after graduating in 1994. In mathematics. I am a near-pod certified educator, verified educator on Kaut Academy, and a puzzle coach and a weekly community leader. I am a global community leader for GEM, Global Education Network. In addition to teaching, I deal with gamification and coding. I write mathematics texts for an Italian platform, Edboom.it, that converts them into educational videos. I write for a website about great mathematicians and maths anecdotes. I am interested in teaching methodologies, digital tools to be used in teaching, and I disseminate my knowledge throughout various international conferences. I am specializing in sustainable development goals of the 2030 Agenda, in particular Goal 4, ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. I'm very proud and grateful for being a speaker for IIU during this session. I take the privilege to be a trainer and resource person for the training session by the Training, Learning and Development Department of the International Internship University. International Internship University, IIU, is a leading virtual education system and global bank federation, which is the most valuable and trusted worldwide and well-reputed in delivering innovative programs. Globally, it is a trusted name for quality training programs and is committed to providing better virtual education to all the young learners of the globe. In a short span of time, IIU has spread its wings in 195 countries and 6 continents under the strong leadership of its visionary founder, Ms. Peyush Pandit Sir, a committed and inspiring social activist, a passionate educationist from the last 2 decades, providing education to students from various social and cultural backgrounds. Today, I want to speak about Vedic mathematics. It's my topics. Let's begin. I'm sure that very few of you know from Vedic mathematics. That is that quick mental calculation system based on a list of 16 sutras, aphorisms in Sanskrit, discovered in the early 90s by the Hindu mathematicians and Maharaja Bharati Krishna Tirthai. His calculation strategies are decidedly creative and can be applied to a great variety of situations. Vedic mathematics is a more flexible and creative calculation tool. I have often wondered where mathematics was born, and doing some research, I discovered that one of the states that contributed to the birth of this discipline is India. Thanks to its numerous discoveries, India played a fundamental role in the development of mathematics, which took place between 1200 and 200 BC. In fact, the first mathematical studies were carried out around 1000 BC. Try entering a forest and feeling the harmony of nature or listening to the sound of sea waves. Would you ever have said that this corresponds to the harmony of numbers? Mathematics can be within everyone's reach because numbers are our proportions, and the proportions present in nature. Numbers are the basis of the development curve of the trends of life. climate, history. Furthermore, a part of our brain is made especially for math. It is this part that makes us understand, for example, the distance of an object from us, or how to divide an element, or to know the quantities. Often, the word mathematics makes adults think of something difficult, of negative experiences. Teaching mathematics to the new generations in a flexible, fun way as a direct consequence of nature becomes a stimulating subject for children, a subject in which they are no longer the object of teaching, but the subject of learning in a logical, creative, and intuitive way. What has been discovered is that Vedic mathematics, in addition to being a neurobic of the brain, facilitates the calculation procedures, leading to fun and pleasure. In fact, thanks to the word formulas called sutra, this mathematics flows into the mind in the same way our brain works. Let's begin from zero. It is important to remember that the whole Western world is indebted to India for the introduction of the zero symbol. In fact, Greek culture had always had the terror of emptiness and non-thickness, and had never introduced a symbol to represent it. We think of the Greek and Roman numbering system and the need to make practical calculations of the use of the abacus. The Hindu notations was introduced in Arabia in 770 AD, and then in Europe by the Arab, in Italy by Leonardo Pisano with his Liber Abaci in 1202, introduces the 10 symbols. Thanks to the introduction of a round things to indicate zero, the modern numbering system for integers has been completed. Even if the appearance of the figures was very different from the current one, the basic principles were still acquired. The Indians knew that an equation admits two routes of solutions that could be negative or irrational, and they knew the calculation rules. A plus 0 is equal A. And A minus 0 is equal A, and A multiplied by 0 is equal 0. The 0 was treated like all other numbers, and not as a number that represents absence or quantity, like today. With the introduction of the 10th digit, the modern integer numbering system was completed, which allows you to write any number, however large, in any case small, without introducing new symbols. It is based on three fundamental principles: decimal base, positional notation, different symbols for each of the 10 digits. This zero brought about the revolution in arithmetic and thus appeared as something miraculous. From this mystical concept, there were a number of expressions that remained in the language and that precisely hinted at something secret, mysterious. The Arabs called zero cifr, which in Latin became zephyr, hence zero. For other languages, cifr became cipher instead. That was something mysterious is revealed by the phrases derived from cipher, that is in cipher, decipher, etc., which all indicate something secret. And these all the more so since, as we have seen, the Arabic numbering was hindered by the traditionalists and even prohibited by the church. It was in a council of cardinals in 1299 that the use of Arabic numerals was expressly prohibited. Even the major art of the traders of Calimala via the Firenze in the same year issued a similar provision. But it is certainly that many merchants used the new system in secret. These prohibitions helped to increase the mysterious in the number. The Indians developed excellent procedures and great technical skills, but they did not bother to justify the rules used. Their works constitute a collection of rules and problems, but they lack a logical arrangement between the various parts. India is not only the homeland of zero and the numbers that the Arabs brought from India to Europe. In fact, between the 4th century BC and the 3rd century AD, Indian mathematicians were the first to develop research on set theories, logarithms, 3rd degree equations, 4th degree equations, square root extraction, finite and infinite powers, and algorithms for the computation of irrational numbers. And now let's speak about Veda. Veda means knowledge. Vedic mathematics is a mathematics that dates back thousands of years and is contained in the Atharva Veda. It was rediscovered in the last decades of the last century by Bharati Krishnathirsthai, who reconstructed the ancient Vedic method. His study was taken up by Kenneth Williams, who adapted it to the Western method. For some years, also an Italian teacher, Anna Foligno, has been teaching this method in Italy and training the teachers so that adults and children and teenagers can receive a concrete help to understand with ease, fun and creativity, a complete mathematical system that can be used in study and in daily life with the same ease with which the word is used. The ancient system of mathematics was rediscovered from the ancient Sanskrit texts known as the Vedas between 1911 and 1918 by Bharati Krishnathirsthai, who died in 1960. The Vedas are very ancient texts written between 300 BC and 700 BC and contain sections on medicine, ethics, metaphysics, psychology, architecture, music, astronomy, grammar. There are 4 Vedas. The last one, called the Atharva Veda, contains the Vedic mathematics, called the Ganita Sutras. Bharati Krishna was a scholar of Sanskrit, mathematics, history, and philosophy, studied these texts, and after long and careful investigation was able to reconstruct the mathematics of the Vedas. Bharati Krishna wrote 16 volumes exposing the Vedic system, but these were inexplicably lost, and when the loss was confirmed in 1958, he wrote an introductory volume of Vedic mathematics published in 1965, where he explains the new approach related to the truth of numbers and of magnitude, equally applicable to all sciences and arts, underlying that great and true knowledge comes from intuitions, very different from the modern method. This book was published in 1965, 5 years after his death. According to his research, all mathematics is based on 16 sutras, or word formulas, that describe how the mind naturally works, giving the students a great help in the method. An example is the vertical and crossed Veda, for example, one of these. Kenneth Williams discovered the book Vedic Mathematics in 1971 and developed its content, applying the system in other areas not covered by Bharati Krishna, creating a structured and complete system that goes from elementary to university and useful for life. The system not only provides surprising general and special methods previously unknown to modern mathematics, and is such more coherent and integrated. Vedic mathematics is a system of mental calculation, as told it can be written. Vedic mathematics is the first element in the development of the combined logical creative faculties. It is that important basis for undertaking a harmonious intellectual and learning development that is respectful of all types of intelligence. Vedic mathematics created in India is in very ancient times, was developed in harmony with our brain, and this makes it easy to learn and remember. It's ultra-fast and effective methods and aids. Numerical expressions in the Vedic text. Since the Vedic texts have an eminently religious character and are written by poets, one cannot expect to find sufficient information for a systematic description of the mathematical knowledge of the time. It is only possible to identify names of whole numbers, sometimes listed in sequences, of elementary fractions, of simple geometric figures, and also to find elements on the practice of mathematics. The term Ganaka, for example, he who calculates or calculator, appears in a book own collection of the by Saint Jean, and in another book, Brahmana of the Tatiria school, in the list of people to be sacrificed on the occasion of the human sacrificial rite. However, it should be noted that in the list of this book, the Ganaka destined to be sacrificed to the divinity of a marine animal is usually identified with an astrologer, even if in the same list before the Ganaka there is already an astrologer, star watcher, called the star watcher, sacrificed to the divinity of wisdom. In this book, on the other hand, the Ganaka, which is sacrificed to singing divinity together with a vina player, a stringed instrument, is presumably connected to music. A list of 18 fields of knowledge, starting with the 4 Vedas, appears in another book. It includes, among other things, the terms knowledge of the stars and rasi, a term which generally means quantity, number, and which, according to some here, would indicate arithmetic, as the data says in 1962. We do not know if in the Vedic era symbols were used for numbers. According to some scholars, the term asta in the compounds Astarkani and Astarradam Iraniam would refer to a symbol to indicate the number 8, for example, but the hypothesis is rejected by others, for example, in data 1986. The Rig Veda, Veda of the hymns, contains a number of numerical expressions. Vedic poets had the particular fondness for 3 and 7 as sacred numbers and frequently used the multiples of these, such as 3 multiplied by 7, 33, which is equal 3 multiplied by 11, 3 multiplied by 50, 3 multiplied by 70, 3 and 333. Which is equal to 3 multiplied by 111. It has been hypothesized that the number of goods 3339 given by Rig Veda represents the sum of 33, 303, and 3003. Maiti said in 1995. Although there is no evidence that the Indians of that time used the positional numbering, this sum did not have to present great difficulties, as their number system was basically decimal. They used the terms Ika, Dasa, Sata, Sahasra, and Ayuta to denote the numbers 1, 10, 100, 1000, and 1000. For multiples of this number, they often use an expression based on 102 or 103. For example, 2 multiplied for 103 is equal to 20, or multiplied 102. The words 100 and 1000 were sometimes used in the sense of a certain number. Thus, Indra is said to have destroyed 100 ancient fortresses of Sambara and killed 100,000 courageous men of Archin. The number 60 also seems to have a particular importance for Vedic poets, since expressions such as 1060 cause 60,000 and 99 kings and 60,000 ayutas of horses, but we are unable to evaluate their significance. The Rig Veda also contains references to the most common fractions of the unit. A half, a quarter, part literally foot from the 4 feet of a quadruped, an 8th safra finger from the 8 fingers that make up the 4 uves or ko, and 1 divided by 16, kala digito, from the 16 digits of the moon. It does not seem that Vedic Indians encountered particular difficulties in performing addition, subtractions, and probably even multiplication between whole numbers. The division, on the other hand, was much more complicated if there was a reminder. Only Indra and Vishnu were said to have succeeded in dividing 1,000 cows by 3. According to the book, they correctly obtained the quotient of 333 with the remainder of 1. At the time of the Vedic collection of sacrificial formulas, at the latest, the Indians had extended the list of names of the powers of 10 to Eka, Dasa, Sata, Sastras, Ayuta, Anyuta, etc. This list appears in texts of both Ayurvedic schools. These terms are used in count the number of bricks used in the construction of the altars, which increases the geometrical progression of a reason of 10. They appear in sacrificial formulas, mantra, to be pronounced on the occasion of an Nauma, rite of the offering of food, officiated in a certain phase of the Asma Media, the horse sacrifice. In Nauma, a priest makes a series of oblations of clarified butter, honey, grease, barley, to the fire, called Armania, during the night until dawn, reciting mantras that involve the repetition of the following formula, numeral in the dative. The first mantra reads L2 1, L2 2, L2 3, and L2 19, L2 20, L2 100, L2 whole. The last mantra contains the names of the decimal powers mentioned above, from Sata to Parada, L2 to Sata, L2 to Sastra, and so on. And the hypothesis advanced by some scholars, according to which the last 7 terms should be interpreted as the names of the powers from 1013 to 1019, seems to be without a foundation. Vedic mathematics, let's say that first it is based on sutras, word formulas that direct our brain in the type of desired operation. Its characteristics ensure that Vedic mathematics attracts everyone, including artists, writers, as well as logicians. Thanks to the Vedic system taught, children come into contact with the numbers in a serene way. The Vedic mathematics learned from parents gives way to its use in practical life without the need for technological support. How satisfying to be able to calculate a percentage in mind in less than 5 seconds. What self-esteem to calculate the change when shopping before the cashier without the aid of a calculator. Why Vedic mathematics? Vedic mathematics leads to rediscovering the dormant mathematical genius within you. It brings out more security and trust and is a complete mathematical system that includes education starting from elementary school up to university. This mathematics, which represents the original mathematics, becomes a valuable support and an element of motivation for the traditional mathematics. It creates a mental elasticity and gives teachers new tools to make them more exciting and capture the attention of their pupils. It leads to new reasoning, to be more intuitive and to better understand what children are usually taught. Furthermore, children with dyslexia and dyslexia benefits from it. By Vedic mathematics, we mean in general the mathematics dating back to the Vedas, the sacred text of Hinduism, the source of knowledge transmitted orally throughout the sutras, which we can define as aphorisms of Indian wisdom. For some years, Vedic mathematics has been introduced in Indian schools, and the University of New Delhi has organized for the year 2007-08 a course in Vedic mathematics, with the aim of making mathematics more attractive for students. Now it is spreading to the most prestigious American schools, presented as the flagship of their programs. In practice, it consists of a series of calculation techniques useful for developing greater flexibility in mathematical reasoning. Thanks to these calculation techniques, the students can more easily discover new methods of solving problems and realize that there is no single correct method. In this way, schoolwork becomes more creative, say the proponents of Vedic mathematics, and increases the interest in the work that the students have to do in the class. The techniques of Vedic mathematics range from elementary calculus levels that can also be proposed in primary schools to more refined techniques that can only be proposed to high school students or adults. What is the use of Vedic mathematics? The methods of Vedic mathematics allows, for example, to multiply each other 998 multiplied by 997 mentally in less than 5 seconds. They offer 16 basic sutras that can be applied in arithmetics, geometry, algebra, and numerical calculus. They contain simple methods, counting with the fingers on one hand, and complex methods to calculate again without the use of calculators, square roots, and logarithms, enhance logic skills, and allow you to improve your performance in mathematics. The ancient system of mathematics was discovered, as I said before, from the ancient Sanskrit text known as the Vedas between 1911 and 1918 by Sri Bharati Krishnatashtai. The author of the book from which the conversation about the Vedic mathematics is largely derived is Jargardu Swami Sri Bharati Tirthai Maharajai, known as Guru Deva, person of exceptional intelligence. Given the excellent results in all disciplines he had as a student and the contributions of the highest level with the various international institutions given sequentially. But very great and burning was his desire for spiritual knowledge, and so he retired to study in 1911 for 8 years, advanced the Vedic philosophy and to practice the highest and most vigorous yoga sadhana in the nearby forest. Having attained the deepest meditation in the highest spiritual elevation, he was admitted to sacred order of sannyasa, and thus began to travel to every corner of India and the world for 35 years to bring the holy spiritual teaching, not sparingly when health began to fail. He had collected his teaching in 16 volumes, one of each sutra, for each sutra, but deposited in the house of one of his disciples. They have been lost. Only the first has been rewritten, which is one to refer. The hallmarks of Tirthai were an insatiable curiosity and an exceptional memory. He first obtained the baccalaureate in 1902, ranking first, and the following year he obtained the degree of master in all disciplines chosen, obtaining the maximum score. He was also a deeply spiritual man who practiced yoga meditation intensely, and in 1925 he became head of a traditional Hindu monastery, Matas, in the city of Puri in the Bay of Bengal. The Vedic mathematics that he claims to have discovered consists of 16 aphorisms, sutras, that our Tirthai claims to have drawn from the Vedas, even if in the Vedas they are not found in direct form, but have been in some way deduced thanks to them, to the revelation. The Vedas are a set of sacred texts written in Sanskrit that form the basis of that heterogeneous religious movement called Hinduism. And now a little dictionary, a small dictionary. Sutras means aphorisms or formulas used in Vedic mathematics. Dharma is the sum of the all knowledge necessary for life, while both individually and as a community. See the source and container of all knowledge comprehends. Ayurveda, anatomy, physiology, hygiene, medicine forget physical well-being here and now. Dhanurveda, military science. Ganarveda, Ved, science and art of music. Satarpai, see architecture, engineering, and each branch of mathematics. Vedangas, grammar, astronomy, lexicography. The Vedas are the oldest documents of the human spirit that we possess, written in a hierarchical with the oldest known so far evidence of social organization, far prior to rise of Greek civilization, antecedent to the most ancient remains discovered so far of the Assyrian Empire, probably contemporary only with the most ancient Hebrew writings, and later only to the Egyptian dynasties, of which, however, very little is still known beyond the symbol names. However, it is difficult to give a precise dating. The Vedas, according to the Hindu philosophy, represent an exhaustible source of knowledge, both in spiritual and material matters. Their richness comes rather than from the laborious inductive and deductive methods of traditional mathematics, from a direct gift or revelation received by Joshis after a long journey of meditation, straight from the perfect, immaculate source. In any case, any sequence and lighting must be demonstrated with a rigorous logical method. We must not confund the mysteries of the Vedas with the dreaming eyes of the poet or the seer, but with the attentive and critical eyes of the physicist. And the physicist is deliberately chosen as an emblematic representative of scientists, because just recently, ancient knowledge and modern physics have found significant and suggestive correspondence and parallels. The premise, the basic premise that the universe we live in has a basic mathematical structure, and that therefore to know a fact and obtain a result nature and obtaining the great Vedic philosophy. They realized that the visualization of reality takes place throughout a mysterious work of numbers and figures, and they deduced the mathematical philosophy. And now there is the list of the main sutras. Let's read it together. The first, for one more than one before. The second, all from 9 and the last from 10. Third, vertically and crossed. Fourth, transpose and apply. 50, in the Samukai is the same, it is 0. Sixth, if one is in ratio, the other is 0. Seventh, by addition and subtraction. Eighth, by the complexion or not complexion. Ninth, differential calculus. 10th, by the efficiency. 11, specific and general. 12th, the remainder by the last digit. 13th, the last and twice the penultimate. 14th, by one less and then the one before. 5th, the product of the sum. And the last, all the multipliers. These 16 aphorisms were mathematical formulas according to Tirtai, even they seem like esoterical or numerological formulas. Tirtai said they were rules for making calculations. For example, number 2, one that says all from 9 and the last from 10 applies when you have to do a subtraction in which a power of 10 appears. For example, if you want to calculate 1000 minus 653 is solved starting from the left by subtracting 6 from 9, you obtain 3. 5 again from 9, and then you 3, and you obtain 4. And then 3 from 10, the last, and you obtain 7. So the result, the final result is 347. With the 16, these 16 aphorisms, Tirtai argued that mathematics that students learn over about 15 years of study could be learned in 8 months, only 8 months, since he was not only a great scholar, but also a great speaker. Wherever he went, he achieved enormous success. People were amazed by his method and wondered in amazement if Vedic mathematics was mathematics or magic, to which he always replied, but it's magical until you understand it, then it's math. At the age of 82 in 1958, 2 years before his death, he went to United States, and among the places where he spoke was also California Institute of Technology. He said he had studied and loved mathematics and metaphysics in equal measure without any difficulty. And he went on to explain how he had drawn his famous 16 aphorisms from Vedas, and discovering what other scholars of those texts has missed. But let's begin to do magic. And now let's see some rules used with the sutras and Vedic mathematics. First, let's see how we can multiply two numbers between 11 and 20. To multiply two numbers between 11 and 20, add the units of the second number to the first number, and then multiply the result by 10. To this, add the result of multiplying the two units. For example, in this case, we want to multiply 13 by 16. So I said you have to add 6, the second unit, the units of the second number, to 13. So you have 19. Then you have to multiply it by 10. So you obtain 190. And I had the multiplication of the units, that is 3 times 6, 3 and 6, which is 18. I add it to 190, and I get the result, 208. It is very easy. Then let's see how to calculate the square of a number ending with the 5. To calculate the square of a two-digit number ending with the 5, proceed as follows. Multiply the 10th digit by its next, and follow the result of this multiplication by 5 squared, that is obviously by 25. For example, in this slide, you can see 75. We want to calculate the square of 75. So you have to multiply 7 by its next digit, that is 8. So 7 multiplied by 8 is 56. Then you can write 25, and we get 5,675. And in general, how can we calculate the square of two-digit numbers? To calculate the square of any two-digit number, proceed as follows. Listen to me. On the left or right of the square of the 10, in the center, multiplication among the digit of the 10 with the digit of the whole multiplied by 2. And on the right, the square of the digit of the units, obviously taking into account the carryovers. In this example, I want to calculate the square of 68. On the right, I write 6 squared. In the center, and the multiplication among 6, 8, and 2. 2 stays for the square. And on the right, the square of 8. 8 squared is 64. So I write 4 and carry 6. And I write 6 in the center. The multiplication among 6, 8, and 2 gives 96. As a result, I add the 6 of the carryover I had before, and I get 102. Then I write the 2 and carry the 10 on the left, under the square of 6. So I add this to the square of 6, thus obtaining 36 plus 10 equals 46. The final result is therefore 424. In general, if you have to calculate the square of a two-digit number, and it's very easy, as you can see. And now let's see the multiplication method of Vedic mathematics works with two-digit numbers. For example, with this multiplication, 98 multiplied for 62. Clearly, you will have to subtract for 100. So 98 minus 100 is equal to minus 2, and 62 minus 100 is equal to minus 38, to be written next to the numbers to be multiplied. At this point, using the diagonals, we obtain the first two digits of the solution. 98 minus 38 is equal to 60, or similarly 62 minus 2 is equal to 60, which will be written under the matrix in this way. In this matrix, I wrote 98 here, minus 2, 62, and minus 38. So 98 minus 38 is 60, such as in the other diagonal, 62 minus 2 is always 60. While the two last digits will be obtained from simple multiplication, or minus 2 and minus 38, and it is 76. And so the result is 676. There is also an algebraical explanation of this. I want to explain you why we use this rule. In fact, if you multiply by x minus a by x minus b, you obtain x multiplied by x minus a minus b plus ab. So in the same way, 98 is x minus a, so 100 minus 2, and 62 corresponds to 100 minus 38. So applying this rule, it is equal to 100 multiplied by 100 minus 2 minus 38 plus 2 for 38. So we obtain 100 multiplied by 98 minus 38, or 100 multiplied by 62 minus 2 plus 76. And so you obtain the result you obtained before. But it is not only the only technique that can be used in Vedic mathematics to multiply two numbers. The predilection for the elementary solution of multiplication is understood by the difficulty of carrying out these operations by subjects without schooling, or as pure fun in finding variance in the execution of an arithmetic operation. With the aphorism system number T, vertically and diagonally, that I said before, we proceed in this way. If you have, for example, to calculate 61 multiplied by 37, multiply vertically 1 and 7, and you obtain 7. Then you have to multiply 6 by 7 and add 3 by 1. So you obtain 42 plus 3, which is equal 45, and I write it here. Then with the carryover, finally multiply the two numbers in the first column on the left, 6 multiplied by 3 vertically, to which the carryover of 4 will be added. So we obtain 6 multiplied by 3, 18. Then you add it to 4, and you obtain 22, and 5 and 7. So the result is 2,257. The system also applies to multiplication of numbers of 3 or more digits, breaking down the technique by two columns of numbers starting from the right and reporting. This is the rule to multiply a number by 11. Just to follow a very simple procedure. Add the 0 on the left of the number that you want to multiply. For example, here I want to multiply 56,276 multiplied by 11. So you have to add 0 on the left of the number that you want to multiply. Then you have to rewrite the number of units, in this case 6. Then you add this figure, which in our case is 6, to the figure that precedes it, that is 7. It makes 13. But you write 3 and carry 1, and you write 1 here. Then you have to add 7, 1, and 2, and it is 10. So you write 10 and write here the carryover. Then here you have to add 2, 1, and 6, and you obtain 9, and you write 9 here. Then you have to add 6 and 5, and you obtain 11. You write 1 and carry 1 here. So you have to finally 5 plus 1 plus 0, and you obtain 6. So you obtain 619,037, and this is the result. Geometric knowledge. Before concluding my speech on Vedic mathematics, I would like to point out that I did not deal only with the arithmetic and not with algebra, as a friend of mine, a professor, objected, but also with the geometry. In particular, I want to give you some hints on the well-known and studied Pythagorean theorem. It is probable that the Pythagorean theorem is explicitly states and used by the authors of the Subhastra Sutra aphorisms of the construction of altars was already known at the latest of the time of the Brahmana. It is explained how the area of the 5 altars Agni is progressively increased. The base altar, called 7 times Agni, as an area of 7.5 square purusa. A purusa or man is equal to the 8 of a sacrificial with his hands stretched upwards. In subsequent rites officiated by the same sacrificer, it is increased by a square purusa until the altar 101 times each is obtained. The increase in the area probably had to be carried out by taking as purusa a new value, higher than the previous one. The book seems to refer also to the inverse of the Pythagorean theorem, which can be studied by saying that if the sum of the areas of the squares constructed on the 2 sides of a triangle is equal to that of the square constructed on the remaining side, then the 2 sides form a right angle. The passage in question provides instructions for the construction of the space where the greater altar stands, which must have the shape of an isosceles trapezoid, with a greater base of length of 30 vikrama, minor base 24, and day 8 36. It does not explain how to construct such a trapezoid, but it is likely that the right triangle with the sides 15, 36, and 39. The Pythagorean theorem, one of the 2 treasures of geometry, as Kepler wrote, is a topic still debated by historians regarding its origins and authorship. Although it is known clearly that the theorem linked to the name of Pythagoras is a legend, as it was known not as a general theorem, but in the form of a general rule at least 1,000 years before him. The substratas aroma apagendas, known as the Vedanga of the main Vedas. The Vedangas are divided into 6 branches of knowledge: phonetics, grammar, etymology, metric, Chandan, astronomy and rules of writings and ceremonies, Kalpa. In the last 2 Vedangas, we find the most important sources of mathematics of the Vedic period. The testimony is generally in the form of a sutra. We can define them as aphorisms of Indian wisdom. A large part of knowledge was made more easily memorable by trying to avoid the use of verbs as much as possible and by composing very long names. The Subhastra contained the instructions for the construction and measurement of altars intended for ritual sacrifices. Terms originally meant rules for conducting sacrificial rites, but the word sulba later referred to the length of rope used for measuring altars. Much of that we know about Vedic geometry comes from these sutras. Subhasutra geometry First, geometrical conclusions and explicit states theorems. Second, the procedures for building altars of different shapes. Third, the algorithm tools containing in the precedent points 1 and 2. The most important statement of the first category is the Pythagorean theorem for a right triangle. The current wording of the Pythagorean theorem expressed in terms of sides and diagonals of squares and rectangles is found in Esposito and Catayana. And the Bayudan version says, listen, the rope that is stretched across the diagonal of a square produces an area that is twice the size of the original square. The three subassolutas provide a more general proposition. The rope stretched along the length of the diagonal of the rectangle forms an area equal to the sum of that formed by the vertical and horizontal sides. And then I want to speak to you about Alex Bellos, the Guardian journalist with a degree in mathematics and philosophy, and author of The Wonderful World of Numbers. Argues in general that the technique of Vedic mathematics are faster and more practical in carrying out these elementary arithmetic operations, comforted by some teachers who use the method by observing how students learn more easily. Their thesis is, it is true that with the classical system you have or should have constant control of what you are doing, while the Vedic technique is more obscure, but the boys are able to perform multiplication faster. So they wonder why continue to teach the classic method to pupils who cannot understand it and not an alternative one, perhaps teaching the classical one later on. Mathematics is rigorous, but it is also creative. There is often no single method to obtain a result, as my friend said. Intrigued by the simplicity of some of the techniques of Vedic mathematics, Bellos carries out a research and discovers that the system of diagonals, vertically and diagonally, 3 or Sutras 3, is also reported by Leonardo Fibonacci in his Liber Abaci, plus the aphorism all from 9 and the last from 10, was a system used in the 15th in many arithmetic textbooks. Furthermore, it is conceivable that from these two predecessors of the Vedic tricks derived the use of an X in the multiplications to indicate precisely the diagonals, as we have seen before. Vedic mathematics is a set of techniques discovered and rediscovered by a profound thinker with the aim of teaching arithmetic and stimulating the creative aspect, which is also fundamental in mathematics. Indian mathematics has provided other important contributions to mathematics, and even these calculation techniques, although often known and used previously, demonstrated the importance of the Indian influence in this subject, as well as the importance of imagination in solving problems, stimulating the curiosity, and providing fast calculation tools. In conclusion, with the Vedic mathematics, pupils progress faster. This type of mathematics has positive aspects as it improves the learning of traditional mathematics, as well as it is fun, easy, and passionate. And all these characteristics are the basis of any learning. Knowing another method can be a stimulus to deepen and develop mathematical creativity. The characteristics of Vedic mathematics is that it creates security and self-esteem. There are different ways to find solutions. Therefore, it favors cognitive development and problem-solving skills, very important for pupils with specific learning disabilities, for example. Recent studies have shown that using the creative hemisphere in mathematics is essential for harmonious development and improves intuition and emotional involvement. It is important to note that ancient Indian scholars used this original computation system in all known branches of science. These sages, having a great understanding of mathematics, realized that every science available for the knowledge of man was directly or indirectly associated with the mathematics. So they developed an efficient and simple methodology for dealing with the mathematics. All the great Indian mathematicians were students of Vedic mathematics. The algebraic calculation behind Vedic mathematics has, in addition to an undoubted cultural value, also a great didactic value. Calculating quickly in mind throughout the sutras is, in fact, extremely stimulating for students. Furthermore, Vedic mathematics helps to develop greater flexibility of reasoning, demonstrating that there is no single and universal method of calculation, and has been introduced a few years ago in major Indian universities, as I said before. These fast calculations techniques were tested for the first time in England, where, for historical reasons, there was a great attention to Indian culture, and where illustrious mathematicians such as Kenneth Williams or Satish Sharma were able to experiment this method with the students of disadvantaged classes, obtaining really great school and educational achievements. So why not delve these into fascinating banks of mathematics? My speech is ended. I want to thank you all. I want to thank IIU for the great opportunity of explaining my knowledge about Vedic mathematics, and I hope it has been interesting for you and open-minded for all of us to learn new techniques of a new branch or an old branch of mathematics, which can help us to be faster in our calculation and more creative with the mathematics. Thank you and bye-bye.